Okay, thank you all for coming. Can you hear me in the back?
Yes.
Yes? Okay. Today we're going to talk about Cascade Retain, which is a tool for intelligent data retention on PostgreSQL for foreign key analysis. It's also for MySQL, but we've ported it to PostgreSQL.
Can I ask you something?
Yeah.
Is it possible to increase the AC?
What?
Increase the AC because
You wanted to?
I'll go ask. I'll go ask. Right back. You keep going. You keep going.
Okay, so this tool should do.
לא, increase זה לעלות או לא.
להעלות את הקירור או להעלות את החירור?
כן, זה השאלה. Okay, so we're talking about automatic deletion of related data, and we need automatic because I work at a startup and the schema changes a lot all of the time. So I wouldn't want the developers to be stuck on retention task. So I would like to have automatic discovery on a single large database, and a large, I mean startup large, not enterprise large, so a big database but not enterprise one, with all data associated with a specific customer. To illustrate is an example of a database. Once a person is leaving, we would like to find all of the information that related to this person and then delete this information from the database. In this case, we will go to the ownership options and then ownership history, but notice that there are several paths to go from a person to a given table, and it makes stuff more complicated. Next, for compliance reasons, we need to keep some of the tables that doesn't have personal information. For example, audit log or access log. So we will have a config file which specify for every table should it be deleted or should it be retained. And in just 30 minutes, you'll know how to build such a tool, even though I hope you wouldn't need to without this long road that I did. And maybe you could offer me a better way to do it. So at start, when I got the task, I searched for tools that can give me such an option. And mainly lineage tool or configuration tool gave me something similar, but it didn't give me an object level connection that enabled me to delete all of the related information. So I didn't find a correct tool to use, so I wrote one my own. So I'm Daniel Balush, I'm principal software engineer at Ilios. I'm the first employee in the company. About 5 years ago, I have 10 years of industry experience. Feel free to connect to me. This is a QR code of my LinkedIn. And please come talk to me. I'm kind of shy, but I'll be happy to discuss it. Ilios is a mental health company. It works primarily with psychologists, where the hypothesis is when a therapist has less mental and time burden of operations, we provide better care, and we see results from thousands of therapists. So meet Cash. He is our, we will do the journey together with him. He's a graduate from accounting, and now he starts to work as a tax investigator. And this is Bones, is the mafia boss. He would like to capture all of his assets and delete them. So we will go to the route with him, and we'll understand all the connection that is required. He's the new generation of task investigator, and he would like to use this thing called computers. I'm doing an overview of the connections. Most of you most likely know it, but we will do a fast refresh. So we have different connections in the database, and we will need to know how to handle each one of them. So the first is it's a simple foreign key, which is a one-to-many. we have two tables, one of them references, another table where the secret word is references, the magic word, and it gives us also the referent integrity. So there are two tables, one reference another. In order to achieve a many-to-many, we use the same thing again. We have a one-to-many with a junction table, and another table does a junction table, a one-to-many with the junction table. This gives us that a person can hold shares of many companies, which is the LLC. LLC is like more חברה בע"מ, and the LLC can have many persons holding its shares. So this is how many-to-many is built. And the last one is one-to-one. There are different ways to implement one-to-one. Not sure this is the best, but it's correlated to the previous one. We do the same thing, and we add a unique not null on both of those references on the junction table. So now a person can have only one type of share, which is always only one company. This is more likely to something like a person, and then you do a profile, or something where you take a table and you extend it because you can't edit it. And one more thing that we have is the cascade. This is how we can populate change in the system in a simple way, and you can either restrict or cascade. So when you do a restrict, if a person holds a share, you cannot delete the person while you have this connection. And if it is a delete cascade, once a company issues the shares and you delete the company, all of the issued shares will be deleted. Okay? Great. So first thing Cache we're planning to do is to add cascade delete to all the relevant tables and just delete bones from the system, bones not the person, and he thinks that his job is done. And now there's a question for you. What type of relationships Cascade Delete will not help on?
Many-to-many.
Good. So one example is really that on many-to-many Cascade doesn't work. The reason is because at Cascade Delete, once you delete a person, the share will get deleted, but you have no way to come back to the company. Another reason I didn't want to go the cascade route is that editing cascades or triggers, that we'll talk in a second, is a change that affects the entire production database. So such a large change requires extensive QA, and it's also making the risk larger. So I always try to do minimal change to go faster to production. In general, what doesn't reach production is a lie, right? We want to go to production fast, so we need to make sure our changes are off the critical path. Great, so Cache is frustrated, he goes down to the -1 where all the DBA sits. It's dimly lit wood, nobody talking to each other. And then he asks one of them what should he do, and the answer is custom triggers. So when we talk about triggers, it's get really complicated really fast. And now I have a question. Before we talked about one of the problems with the graph. Who can tell us why would this trigger become very complicated?
Debug. Debug.
Debug is one of the reasons. It's hard to debug, to troubleshoot, you mean?
Nested triggers. Nested maybe.
Yeah, so once we have a path, several different paths, it's hard to understand. It's more than that. You don't have guarantee of order on triggers. So if we implement deleting ownership history with trigger and ownership options with trigger, we have kind of a race condition. When I started to play with it, sometimes my code worked and sometimes it didn't. What happened is that some of the times the tables in the middle got deleted, and then I have Iceland of uncorrelated data that I'm not being able to delete it. So we have a deletion of order problem. Okay. Next one, he heads over to the developers. The DBA didn't help, and they offer him to go and talk to Daniel at the CISO office, which is me. He came over to me and I told him, no problem, sit with me, we will easily do it with the ORM. This is a real image of me working on this code for very long hours without understanding that what I'm doing is about to reach exactly the same problem as before. So when we talk about an ORM, basically it allows you to write code at your own programming languages without writing raw SQL. It also manages the migration and the schema for you. The reason that I went the ORM route is that the architecture of Ilios is that we started with a single small web server written in Django, and we did all of the data operations from the laptop using the ORM with management command. Over time, the R&D grew, and we had a whole lot of tools, adding Airflow, Kubernetes job, and so forth, when the rule was that every write is using the ORM. So all of our business logic is encapsulated in this ORM. If you only want to read, like business tool, like superset and so forth, you can use whatever you want. But all of the writes are using the ORM. The next step is migration to Postgres. The main issue is because that MySQL doesn't support schema changes inside the transaction. We had a major issue with it, and there is better Django support for PostgreSQL features. So this tool supports both of them. Okay, so how we map it with the ORM is that this is an example of how a class for a company from before is looking like. And I added a function that maps the roles to a given person. In our case, it was a bit different, but it's the same. So you filter all of your relevant information. Now, the easy part is that it gives you a way to do the dot. All of the foreign key and many to one, it gives you a synthetic sugar over it and lets you filter throughout the condition. So it's very convenient to filter into deeply nested relations. Some of our relations in our database are sometimes 4 or 5 level deep. And then you do a dot equal, and you finish. And if you write it with SQL, it takes you a bit more time. Okay, so who can tell me again at what problem we are hitting with the ORM? The deletion order. I ran the unit test. Because I'm a donkey, I usually work and then I think, unfortunately. So I write the unit test again and I run it, and they are green and I'm happy. Usually when something is working, I do it 1,000 times. Sometimes it started to fail. And I draw the graph every time, how the relations are looking, and I had the same problem. Great. So we give up. Not yet. Usually when stuff gets complicated, I try to model it into a graph. And if it doesn't work, I do several scans and iteration of the graph. And every time I try to add another information or layer into it. So let's go over the solution together. On the first step, we will start to build the nodes of the graph. So using the information schema, we can get a list of all the tables in the database. And we will build a node for each one of those tables. So now we have a graph without any edges. Then we go back to the same information schema and we get out all of the foreign keys. We go for each node and get its foreign key. The foreign key gives us all the information that is needed to build the relation and later the joins. We have the source table, the source column, the target table, and the target column. And then we add the edges to the graph. Now notice that the graph here is not directed. This is by purpose, and Cache will just tell us why. It has to be undirected so the deletion doesn't stop in the junction table from before. And before we couldn't go from a person to LLC because it was a directed graph. Now it's an undirected graph. This is also why the configuration file is critical, because the Cascade usually helps you to prevent unwanted deletes, right? But sometimes you want to delete the deeply nested information, so in an undirected graph you can really get all of the relevant information. Now we go for every one of the tables that we are planning to delete, and for each one we build the route. Now to build the route, I used a graph lib with a built-in find all path method, but you can do it on your own with DFS and backtracing. It's one of those classical problems. And then we found the first route from this, in our example, from LLC into a person, and we save it in a side, and then we find a different path and we save it. At some of the tables at our database, there were 150, 160 routes, which are too big. So I added also a limit of how nested you can go. But the median was, let's say, 10, 15 different routes from the source table to the target table. A note here. When I'm programming, I'm trying to prefer determinism over runtime speed. It makes testing much easier because then you can do regular assertion. Even if the programming language gives you a way to compare unsorted lists, I find it much better to always work with a stable sort. The difference between a stable sort and a sort that equal objects always return in the same order. And this makes also troubleshooting of production issues much easier, because if you can get the relevant data, you can make it on your own computer also. So it is this example is in Go, but almost every language gives you stable sorting interface. The next one is that it's good to prefer integration over unit testing, especially on code that relies on the internals of the database that you're using. I need this code to both support MySQL and Postgres, and a very specific version of each one. So in the future, if I will need to support a different version, on my side it's running a different Docker version and running the same integration suite. I'm trying not to use mocks and not to use fakes whenever possible. And today the computers are pretty fast, so usually it's okay. Okay, so let's start to create this big join query of the route. So this is the route that we are talking about, and we're going to select something, we'll be back to it soon, from the first table, which is LLC, dot what? I'm going to ask you, where do I bring the column that I need?
Where? What is the question?
Now I need to get a column. Where can I get this column?
The keys.
Yeah, the keys. We have the keys from before. It's the same information that we carried before, the foreign key relation. So we're going to use this foreign key relation to build all of the joins in a dynamic manner. And I move one first, but now we need to know what column do we query, okay? So the column that we query is the primary key column. I have an assumption that all of the tables have a single primary key column. These assumptions hold in the database that we have, okay? If it wasn't a correct assumption, I need to change my code.
What about the many-to-many table? The table that connects the two can't have one. It can't have one column as a primary key.
So you will have
I need
two.
to check it. I think it has a primary auto-incrementing column, and then you have two foreign keys that are unique.
Primary key have to be unique.
Yeah,
It's the description of
yeah.
primary key.
Yeah, I know. So I think the table doesn't look exactly like that. Usually when we create a table, it has a auto-incrementing primary key. But so. Okay, so we're getting this primary column key and we put it in place. So now we have select ID. This is the entire query for a single route. Man, this is getting ugly. This is really getting ugly. At this type, the code base is becoming a bit hard to understand and to debug. And when I explain to somebody else in the team what I'm doing, he's got those glass eyes blue. So now we have a multiple path. Each one of the paths has a query, but they're all returning exactly the same type of information. They're all returning only primary key. Only the primary key. So how do I run multiple queries at once and get only unique results? How do I run multiple queries at once and get unique results from all?
Stop procedure or?
But except
A bit different. It's
Union.
union. Yeah. Using union, I'm running all of those queries because those queries represent different paths, right? All of them in the end are primary keys of the same table, and then I'm serving it in a before delete table. So I will have a before the delete table for each one of those tables. And I must first get all of those tables ahead, because otherwise I have the same problem of deletion order. Okay? I have to query all of the database first and to save it, and only then I can delete. After I finish collecting all of the information, I can delete, and the delete is done by joining the table with all the primary keys I've gathered with the original table. And then I know that I'm deleting only the information that I plan to delete. And we just talked about this. Okay, what about verification and metrics? Because management love those. So we're doing pretty much the same. Instead of using a delete, we're doing aggregated functions. We do a count, and we can do other metrics here. And this is always good anyway to do like aggregation before big deletion. It helped me to find some problems we're going to talk about soon. Okay.
By the way, you can start with begin and not commit. And after you see that the select count is okay by what you calculated. I mean, if you saw there is 1,000 rows that you need to delete, and you do the delete and begin to run. And then you do the delete, and then you see that you deleted exactly, then you can do the commit. And then, even if you did mistake, worst case scenario, you can do rollback, and nothing will be deleted. So, it's another way to check yourself.
That's a good idea. A point for this, all of this is information. From my side, it's historic information. Those are customers that already live. So I feel safe doing a aggregation and then doing a delete, right? I don't need the result to be atomic because I don't have new records that added for this customer, but that's a good one. Okay, so what didn't work? So up until now, we had perfect on the integration test. It's looked perfectly good. Then I replicate the real data I'm going to work on, and I ran the tool with the real data, and I had two problems. One of them is Django generic foreign key capability that lets you, with the same structure of table, to point to different actual tables in the database. It allows you to have dynamic tables, and it's a big mess. What I did at the tool, I excluded it. I said I don't support it. First, I verified that we don't actually use it for personal information holding tables, and then I issue out a command, you don't use it, and that's it. To support it, will require, I need to think about how can I even implement it, but it goes around the entire integrity of the database. The second issue was dirty data. So we had test users, implementation users, integration, training users, and those created couples between different users on the real data. So this was a cross effort of customer success, implementation, and R&D to each one to clean its own data. Created a big report of all the cross information between organizations, customers, and we were able to fix it. And now it's working perfect. So from the technical side, it's a success, it's running, we needed it. But when I look at the overall on the business perspective, in my idea it was a complete failure on the business side, right? I should have stopped 2 weeks in, 1 week in, and to consult with my peers in different companies and to find out how they are using it, because this tool is very specific. It will be hard to extend, it will be hard to maintain, and I don't like to build like custom-made tools that I will need to maintain over time. So the call to action, talk retention to me, baby. Please, this is my LinkedIn. Send a retention person in your company to talk to me. I would like to interview him. At the end, after I do some talks, I would like also to publish the state of retention, how it actually being done here in Israel. And I will, of course, will not publish the specifics, but like a guideline, because this is a problem that every company that handles sensitive information needs to handle, and there isn't really a cheat sheet for it. And commercial break. So Elias is looking for a data platform lead to manage all the ETL, Spark, and so forth. If you know a guy that knows a guy, or a person that knows a person, let him talk to me. And there's many other open positions, of course. Okay, so to summarize, we talked today about a tool to delete all of the related information, and it needs to have automatic discovery. We talked about that at the first we need to map this problem into a graph by creating the information schema to get all of the nodes. Then we will build undirected edges again from the information schema. Then we will find the routes from every node to the darkened node. We will use union to run all of those queries together and get unique results. And then we will save it to a temporary table. We got to query first and then delete to prevent the order of deletion problem. And then we run metrics to see everything is okay, the data is clean, and we can delete.